Hi, I'm Sam Roberts from Roberts Geospatial. Welcome to part 3 of my video series on modern raster technology. And in this video we're going to look at raster statistics. So we'll go through some slides quickly and then we'll do a demo. So in the past, statistics have been a bit of an afterthought in raster systems, but in MapInfo Pro and ProRaster, management of statistics is one of the key design elements. So the MapInfo Pro Raster engine goes to a lot of trouble to compute high-quality statistics efficiently for both for legacy rasters and for modern raster formats like MRR. So what are raster statistics used for? Well, the first use is to acquire an understanding of the data that's in a raster. So it can give you information about outliers and bad values and the skewness of your data and the distribution of your data. Statistics are frequently required for raster rendering. So rendering requires transforming data values from, it requires transforming from data values to a color index. And by default, the data transform will be constructed using statistics as input. So this might just be simple statistics like the minimum and maximum values, or it might use frequency distribution, i.e. the histogram, to generate an equal area histogram equalized data color transform. Statistics can be used to do simple data analysis. So for classified rasters, the count of the number of cells of a particular value, which you can acquire from your histogram, can be used to compute the area of various classifications, for example. And the same kind of analysis can be done by focusing on subsets of the data by clipping the raster to a polygon via a virtual raster intermediary and computing the statistics of the virtual raster. And the advantage of that is you get to use the high quality statistics calculation code that's in the engine. You don't need any additional processing code. The next page. So statistics can be computed for each band and for each component of a band in a raster. And complicating this, they can also be computed for an event or over a range of events, and they can be computed for the base resolution level or for some specified overview resolution level if you want to compute a lower quality statistic faster. Furthermore, if you use driver preferences, you can change the field band structure of the raster and that modifies the statistics. So in general, statistics should be computed from the data at the base resolution level. So this is the unmodified and uninterpolated raster source data. And for a large raster, well, this might take a significant amount of time. When you create an MRR format raster, statistics calculation is performed as a standard part of the raster finalization. So when you go to close the raster, it will do all that calculation for you and write it into the MRR. So if statistics are not available and they're required immediately, then they can be computed on the fly. And in order to do that in a reasonable amount of time, the system can target an overview resolution level. So if the appropriate level is targeted, the computation of the statistics will be rapid. However, the statistics will only be an approximation of the true statistics which you acquire from the base level resolution. So an MRR format raster stores statistics inside the file, and once they're computed, of course, you never have to recompute them again, and they're available forever. In the MapInfo raster system, other rasters can have their statistics stored into a GHX file. So this is a text file that is stored alongside the raster. Now, statistics are only saved into the GHX file if they've been computed for the base resolution level, and this may not occur naturally because when you go to render some raster, it will probably go into the overview levels to get statistics. But you can force it to happen via the statistics dialog in MapInfo Pro Advanced. So in the MapInfo Pro Raster system, the type of statistics that are computed depend on the field type and the band data types. And there are 4 different kinds or levels of statistics that can be computed, and they are count, summary, distribution, and spatial. And by default, the system always tries to compute the highest level of statistics that are supported by that field and or by that data type. So if you compute count statistics, the system simply counts all of the valid and invalid cells in the raster. So valid cells may have valid values, or in some instances, in perhaps old nasty rasters, they can have invalid floating point values. These things are all counted for you and detected. Invalid cells, and this is something people don't really know about, invalid cells can have a classification, and they can either be empty or null. And this distinction is used when you're using events to do editing. So that gives you a range of different counts. You've got your sample count, your valid sample count, your invalid number count, your invalid sample count, your empty sample count, your null sample count, and then summaries of those. So the next level up is summary statistics, and these are the sort of statistics that we're all familiar with. So we're talking about the minimum, the maximum, the mean value, variance and standard deviation, and signal to noise. Next level up is distribution statistics, and this is where we compute a histogram, and then from that histogram you can compute quartiles, you can compute the median, and you can estimate the mode. And the final level is the spatial statistics. And in spatial statistics, we look at the change in the cell value from one cell to the next. And this is used in the MapInfo Pro Raster engine to provide some statistics that are useful for generating hill shading. So the statistics that get stored in spatial statistics are pretty much like the summary statistics, but it's just based on the change in the value from one cell to another. So the MapInfo Raster engine uses a single pass to compute all statistics. For a large raster, using a single pass improves performance considerably because the bulk of the time required is consumed reading the data tiles from storage and decompressing the data stream. However, computing distribution statistics, i.e. a histogram, with a single pass is challenging. Traditionally, you would compute summary statistics in the first pass and get the minimum and maximum, divide the data range into a set of bins, and then run through the entire data set again in a second pass to count the number of values that fall into those bins and to build the histogram. Instead, the Pro system does it in a single pass, in a kind of, it builds an accumulated histogram. Now this has some unique advantages. It tends to isolate outliers, and the quality of the histogram tends not to be influenced by outliers, so that's a real positive advantage. So the type of statistics computed depends on the data field type firstly, and then on the band data type and other band properties. So if you have a continuous field, in general we'll try to compute spatial. If you have image field, you'll be looking at distribution for the color components, but for the color itself, which might be RGB or RGBA or something like that, a multi-component color data type, usually you'll just get count statistics for that kind of thing. For classified rasters, you'll get distribution statistics for the index, and the same for image palette. Remember, these are both by reference data fields. And generally speaking, you'll get distribution statistics for the bands and for the components. And you won't get spatial statistics for classified or image palette because we, generally speaking, won't be doing any hill shading on that kind of data. Then looking at the data type of the bands, so decimal, of course, we can get spatial. Small integer, we'll get spatial. And the way that we generate the histogram differs depending on the data type. So if we have a small integer, say from 0 to 255, an 8-bit integer, or even a 16-bit integer, Then we build our histograms by integer counting, and that gives us a very high quality result, the highest possible quality result. Whereas if they're decimal numbers, then we use a completely different methodology. If we have color single component, then we can do distribution histogram statistics. Otherwise, color will just be count. And then some of the other more complicated data types like strings and complex numbers and so forth, we'll just do count statistics on those. So that's it for the slides. Let's take a look at MapInfo Pro and ProRaster and see where you can find statistics in those systems. Okay, so I have MapInfo Pro open, and I have a map here displaying a terrain raster, one that we've seen before. So on the raster ribbon you have a statistics button, so we'll bring that up. And you can see here you can select the raster that you're looking at, so you have to make sure you're looking at the right one. And then down here it will give you statistics. So with a terrain raster like this, we expect right up to spatial statistics. So in here you can see the minimum, maximum, mean, deviation, etc. They're your summary statistics. Down here you've got total cell count, valid cells, so they're your count statistics. It's computed some areas for you. It's also giving you the valid cell extent. They also come out of the statistics calculations, and that's the range of cells which are actually valid. And then some information about the raster width and height, and then the median and mode and quartiles, so that's coming out of the distribution statistics. And going over to this little view, you have a preview of the histogram, and you can see there's an export button here. You can save that data out to a CSV file or something. So that's your statistics for a terrain raster, for a continuous field. I've got here a classified raster. So this is of the US. Some kind of classification, land use classification. There's a city. So if we look at the statistics for this, it's somewhat different. So we're looking at the index field, so that's the zero-based classification index. So it's giving us the minimum and maximum of that, which is 0 to 19. So that's not very useful information. Mean and so forth for that is not very useful. But then it's giving us the cell count and so forth. That's probably useful information. And the statistical information is there too for your distribution statistics. Again, probably not useful for this. If you look at the histogram for a classified raster, it's a completely different presentation. It comes in as a kind of a table with your class ID, the number of cells in each classification, the color, and various information about the table. Now, just going back up to, well, actually, let's not move on from this yet. So up here, we can select the raster that we're looking at. We can then also select the field and band that we want to look at. So we've got the land cover field. I can go down here and select, for example, the red band, which is the color for the classification. And you come in here and look at the statistics, and you can see that it's telling what the statistics are for the red band. It's computed distribution statistics, it's got a histogram and everything else. But the histogram that you see is not for the red. Well, actually it has changed it. So it's still showing you the histogram for classified raster, but now we've got no data because you're looking at a different band. So what you should probably see here is really the histogram graph. So we'll go up to merit. So if we go to merit, you also see that in this case there's no field or band selection because there's only one band in this raster. This is the DTM. You can see here that there's a statistics mode and statistics quality, and then a button for calculate statistics. So I find this a little bit confusing, but I think what this means that if the button is grayed out as it is now, it means that the statistics already exist and you don't need to count them, don't need to calculate them. And for this raster, they do exist. And looking here for the statistics mode, you've got count, which is the count mode, then basic, that corresponds to summary statistics, intermediate corresponds to distribution statistics, and advanced corresponds to spatial statistics. So you can choose which quality you want. Then you can choose this estimate or full. If you go for full, which you should do, it will compute it for the base level, and then it will get stored in a GHX file. If you go for estimate, it's going to go into an overview level and give you an estimate of the statistics, and then you'd hit calculate statistics. So you can't do that with this file because it's already calculated, but probably with other kinds of files like legacy rasters, TIFF files and stuff like that, you can use this system to force Pro to compute the base level statistics. Then they get stored for you in the GHX file and you don't ever have to compute them again. So that's statistics in MapInfo Pro. So in ProRaster, let me just get rid of that one. Oops, go away. So I have ProRaster here on the screen. Let me just shift myself over to there. So to find statistics in ProRaster, there are a couple of places you can go. So firstly, you can go to the raster source editor. So if I go to Merit, for example, you can see here I select the file and then there's an information button. So if you choose complete info and then hit the button, you will get a little dialog come up, and this gives you all the information about the raster. And if you roll down a little bit, I mean, there's metadata information and all sorts. Here we go, we're getting to the field. There's one band. Here's the first band. It's RL. It's type real 4, so it's a decimal band. And here's the spatial statistics for field 0, band 0. So here you've got all your statistics, sample, count. So let's have. So there's your counts, minimum, maximum, blah blah. There's your summary statistics, then your distribution statistics here. It also gives you your spatial statistics if they exist, and then all the data for the histogram is in here. So in this case it's gone for a single bin per line. It may put multiple bins on a line, and there's 1024 bins. So all the histogram data is there. So that's one way to get information in ProRaster. There's a second way, so that's via the raster source editor. You can also go via the data transform editor. And so if we go into raster here and select Merit, you can select your field and band. You can go for default, or you go into manual settings and select the field and band. In this case there's only one. Then you get your statistics here. So here's your counts, your summary, your distribution statistics, your spatial statistics, and you come over here and you get a histogram. So you can see that as either a spreadsheet, there's your count and cumulative count, or you can see it as a graph, and it gives you a couple of stretch options on the graph for the vertical axis, just to highlight the data. So so that's the second way that you can find statistics in ProRaster, and that's via the data transform editor. So if we were just to create a LUT algorithm, and we'll go in and select that same old raster we've been looking at, Merit the whole time. When you get to use the statistics is when you do the data to color transform. So if you look at these various color transformation types, so a linear transform, This will usually transform between the minimum and maximum. That's going to come from statistics. Or you can set all these various different kinds of clips. So this is a percentage clip, this is a percentile clip, which requires distribution statistics. If you put it on manual clip, now it won't require statistics at all because you're providing the limits of the transformation. Logarithmic transform is the same. You can put it on a manual clip and you won't require statistics. The equal area transform and the stable equal area transform, so these are histogram equalized. You're going to need your distribution statistics. And again, you've got your clip options, you've got your manual clip, but that won't negate the need for statistics. You still need them. Sigmoid, lightening and darkening transforms. These also require minimum maximums, or they might require summary or distribution statistics if you choose these clips, or you can put in a manual clip, in which case you don't require statistics. And then all the various other kinds of things, ranges and so forth, will all be based on statistics. So that's where you might get to use your statistics in your color rendering. So that's it for the demo. We've had a look at MapInfo, we've had a look at ProRaster, and I hope you all understand raster statistics now. So stay tuned for video number 4 coming soon.